Hello students, we are studying most important topic from biology, that is inheritance and variation. Up till now we have studied the basic terms used in genetics, then characteristics of pea plant, then the first cross carried out by Mendel, that is monohybrid cross, then monohybrid ratio, law of dominance and law of segregation. Now today we have to study the second cross carried out by Mendel, and that cross is dihybrid cross. We know about monohybrid cross. What is monohybrid cross? Monohybrid cross is the cross between two homozygous parents by considering single pair of contrasting traits at a time, and that individuals formed in monohybrid cross are called monohybrid. That is having the character, that is the single pair of contrasting character, differing in single pair of contrasting character. And in monohybrid cross, the phenotypic ratio is 9:3 and genotypic ratio is always 1:2:1 in Mendelian crosses. Now the dihybrid cross is a cross between two homozygous parents differing in two heritable traits is called dihybrid cross. Or simply, it is a cross between two homozygous parents by considering two pairs of contrasting traits at a time, or the cross between two homozygous parents differing in two pairs of contrasting traits is called dihybrid cross. In monohybrid cross we consider single character. In monohybrid cross we consider single character, while in dihybrid cross we consider two characters. Single character means one pair of contrasting characters, while two characters means two pairs of contrasting traits. Now, example, a cross of pure yellow and round seeded pea plant with green and wrinkled seeded pea plant. A cross between two homozygous parents differing in two traits or two pairs of contrasting traits. One plant is with yellow and round seeds, another plant with green and wrinkled seeds. Here two characters are considered at a time, that is the color of seed and shape of seed. In one plant, this yellow color is with round shape and green color is with wrinkled shape. Now how this cross is represented? It is most important because in a board examination there is one question: give graphic representation of dihybrid cross. Now how it is represented? It is represented as follows. Here first one is phenotype. Phenotype is the external appearance of an individual. One parent is with yellow and round seeds, another parent is with green and wrinkled seeds. When these parents forms gametes, then each gamete receives one allele for each character. Now what is the genotype? This genotype is represented by capital letters here and here by small letters. These are the dominant characters, these are the recessive characters. Capital Y for yellow color, capital R for round shape. Similarly, small y for green color and small r for wrinkled shape. Now when these parents forms gametes, then each gamete receives one allele for each character. That is, the gametes are here capital Y, capital R, small r. When these gametes fuse and form F1 generation, then the genotype of F1 generation is capital Y, small y, capital R, small r, and the individuals of this F1 generation are dihybrid with yellow and round seeds. Okay. Here, law of dominance can be explained as the appearance of the character, or the character which appears in F1 generation is dominant. The character which gets suppressed in F1 generation is recessive. Now the selfing of F1 generation. Selfing means inbreeding. Inbreeding, it is cross between individuals of F1 generation. F1 crossed with F1. Yellow and round seeded pea plant crossed with yellow and round seeded pea plant. But here these plants are hybrid. It is the dihybrid genotype can be represented as capital Y, small y, capital R, small r. Here also capital Y, small y, capital R, small r. Now these parents forms gametes, and there is formation of 4 types of gametes by each parent. Now these gametes are capital Y, capital Y, capital R, capital Y, small y, capital R, small r. Similarly, this parent also forms the same type of gametes. Now, we have to obtain F2 generation, and the F2 generation can be represented by this checkerboard method or Punnett square method. Here in this line, these are the male gametes, these are the female gametes. Okay. These male and female gametes combine, fuse together, and they form 16 types, 16 offsprings. These offsprings are like this. It forms yellow and round seeded, yellow and round seeded, yellow and round seeded, yellow and round seeded. Here yellow and round, yellow wrinkled, yellow round, yellow wrinkled, yellow round, green round, again yellow round, yellow wrinkled, green round, and last one green wrinkled. Okay, it is the representation of F2 generation of dihybrid cross. Okay. Now what happened? Here there is formation of new combinations, and the phenotypic ratio appears as 9:3:3:1. Out of these 16 offsprings, 9 individuals are with yellow and round 6, 3 with yellow and wrinkled 6, 3 with green round 6, and 1 with green and wrinkled 6. Okay. The phenotypic ratio is always 9:3:1. In any Mendelian dihybrid cross, the phenotypic ratio is always 9:3:1. Okay, this is the dihybrid cross. Okay, again I repeat, dihybrid cross, simply a cross between two homozygous parents by considering two pairs of contrasting traits at a time. Example, yellow and round seeded pea plant crossed with green and wrinkled seeded pea plant. In F1 generation, there is formation of new individuals which are dihybrid with yellow and round seeds. When there is selfing in F1 generation, they forms 4 types of gametes, that is 4 types of male gametes and 4 types of female gametes. They fuse together and form 16 types of offsprings, and the ratio, the phenotypic ratio is 9:3:1. Such ratio, that is the 9:3:1 obtained in F2 generation of dihybrid cross is called dihybrid ratio. Now, when Mendel carried out such experiment, dihybrid cross, Then Mendel proposed one principle, and that principle is termed as law of independent assortment. Law of independent assortment. Now this law states that when two homozygous parents with two or more pair of contrasting traits are crossed, then the characters inherit independent of each other. Or when two different alleles for a contrasting character brought together in F1 hybrid, then they separate, they segregate and inherit independently in next generation. It is termed as law of independent assortment. And due to independent assortment, there is formation of new combinations, and formation of new combinations in F2 generation proves law of independent assortment. Okay. So in last lecture we have studied monohybrid cross, monohybrid ratio, law of dominance and law of segregation, and today we have studied dihybrid cross, dihybrid ratio and law of independent assortment. Okay, such process, such study is termed as Mendelian genetics or Mendelian inheritance. In coming lectures, we have to study the neo-Mendelism, that is the deviations from Mendelian process. Okay, students. So, thank you for this topic, that is the inheritance and variation. In next lecture, we have to study neo-Mendelism. Thank you. That was